In this video, we are going to learn how to determine the exact values of trig functions given one function's value and the quadrants. Start with the first example. Given that sine of theta is equal to 1/3 and cosine of theta is less than 0, find the exact value of each of the remaining 5 trigonometric functions. So the way we do this first is determine the quadrant. Now I said earlier you're given the quadrant, but with this basic information you can figure out the quadrant. Mainly that we know that sine is equal to 1/3, which already indicates that y is positive, which means that we're in either the first or the second quadrant up top. And we know that cosine is less than 0, which really means that x is less than 0, so x is negative. So if y is positive and x is negative, that means we're to the left and up. So we're in the second quadrant. Where this comes in handy, I will mention in this next step, we're going to draw a reference triangle, which means that we're going to pick a ray that shoots out into the second quadrant and has its base, its bottom side, along the x-axis. What's nice about this is now I know that the x-coordinate is negative and the y will be positive. So y is positive. We always keep the hypotenuse positive because we're not going to have a negative radius. But now I need to figure out what this side of the triangle is, and if I can figure that out, I can figure out all of these trig values. So using the Pythagorean theorem, I can say that 1 squared plus, we'll call it x squared, since that's the bottom side, is equal to 3 squared. So 1 plus x squared is equal to 9. X squared will equal 8. Taking the square root of both sides, I know I'm going to use the negative square root of 8 since I know my x to be negative since I'm in the second quadrant. And simplifying that gives me negative 2 square roots of 2. But now that I have a reference triangle, I can use this triangle to determine the other trig functions. Cosine being adjacent over hypotenuse, I can write negative 2 square roots of 2 over 3. Tangent being opposite over adjacent, I get 1 over negative 2 square roots of 2. Rationalizing the denominator, I multiply the top and the bottom by the square root of 2, give me negative square root 2 over 4. Cosecant is hypotenuse over opposite, if you remember a review of trig for cosecant. So we get 3 over 1, which is just 3. And secant, which is going to be hypotenuse over adjacent, so it'd be 3 over negative 2 square roots of 2, which when rationalized gives me negative 3 square roots of 2 over 4 when I multiply the top and the bottom by the square root of 2. And cotangent will be adjacent over opposite, giving me negative 2 square roots of 2 over 1, which is just negative 2 square roots of 2. So very quickly, as soon as we draw that reference triangle, we can figure out what all the trig functions values are. Now, if we were very creative, we could have also used trig identities to figure this out as well. And I'll show you one way we can use that in the next example. Given that the tangent of theta is 1/2 and sine of theta is less than 0, find the exact value of each of the remaining 5 trigonometric functions of theta. So really quick, using a trig identity, if I know that tangent of theta is 1/2 and cotangent is the reciprocal of tangent, I already know that cotangent of theta is 2 over 1. It's reciprocal, which is 2. So I don't necessarily need to draw this reference triangle, but it does make the process very simple. But to determine the quadrant, if tangent is positive, I know that can happen in the first or the third quadrant. And if sine of theta is less than 0, that means y is less than 0. So it wouldn't be the first quadrant, it would be the third quadrant, which is really nice, very easy to figure out. So again, when I draw my reference angle, I'm going to shoot a ray out into like the third quadrant area. So remember that x and y will both be negative. So this right here for tangents, again, your angle always lines up with like the horizontal axis to make this easy. It's opposite over adjacent, so it's going to be -1 and then -2. just so I know that x and y are both negative. And again, using Pythagorean theorem, I have negative 1 squared plus negative 2 squared equals this, I'll just call it c squared for my triangle. Maybe you can even refer to it as r squared, since we know we're referencing a circle here. That's usually would be the radius. They'll have 1 plus 4 is equal to r squared. So 5 is equal to r squared. And taking the square root, I get r is equal to the square root of 5. And I'm going to keep it positive since I typically want to keep my radius positive. And that side will always be positive. So going through, I can find sine, which would be opposite over hypotenuse. So negative 1 over the square root of 5, which simplifies or rationalizes to negative square root of 5 over 5. Cosine will be adjacent over hypotenuse, so negative 2 over the square root of 5. But when I rationalize, I will get negative 2 square roots of 5 over 5. Cosecant will be hypotenuse over opposite, so it's square root of 5 over negative 1, which is just a negative square root of 5. And secant will be hypotenuse over adjacent, which would be the square root of 5 over negative 2, or negative square root of 5 over 2. And again, all 6 values. And if you didn't want to use the reference triangle, after you figure out cotangent, you could have also used the Pythagorean identity, tangent squared of theta plus 1 is equal to secant squared of theta, and solve for this value pretty quickly. And just remembering that secant should be negative, since x would be negative in the third quadrant. And now you know how to find the exact value of trig functions given one function and the quadrant.